All right, so if you haven't already taken the quiz, go ahead and stop this video, go back, click on the other link, and take your quiz. The quiz is open notes, and you may use a calculator. All right, hopefully you did okay on that quiz. Go ahead and get out your homework. Let's see. Yeah, okay. Hey, I haven't been getting very many emails from you except from Shepard, who's found one mistake and then he made a mistake. So Shepard, you're at +0 points right now. But please, if you're having any issues, make sure you send me an email. Let me help you. All right, here we go. I'm going to call it the answers. As always, grade your work. Number 1 is 24 cubic centimeters. Number 2 is 98 cubic meters. Number 3 is 180 cubic millimeters. Number 4 is 4 cubic meters. Number 5 is 72 cubic centimeters. Number 6 is 70 cubic meters. Number 7 through 10 had some decimals in them. It doesn't say to round or not to round. I'm going to give you the full answer. If you rounded, but your answer is correct, then it's correct. All right, number 7, 1.331 cubic centimeters. Number 8, 9.261 cubic meters. Number 9 is just 9 cubic meters. And number 10 is 187.5 cubic centimeters. All right, go ahead and answer question 1 on Google Forms. Here's a calendar. You took your quiz. We're about to have 10.7. We'll move on. Next Friday, chapter test. We'll do a chapter review on Wednesday. All right, here's your homework for tonight. Okay, today we're going to do volume of cylinders. Volume of cylinders. All right, last class we started talking about this thing called volume. It's the amount of space in a three-dimensional figure or shape. And we give the units when we do calculating volume. You are literally counting the number of cubes that fit inside the shape. So when we write the answer will be in cubic units. So like, for instance, cubic centimeters or maybe cubic meters. Those are the two different ways to write it. Okay. So last class we did volume of prisms, both rectangular prisms and triangular prisms. And if you recall, for both of those shapes, for any prisms for that matter, that the formula in the book you'll see is V is equal to capital B times H, where B stands for the base area and H stands for the height, or the distance between the two parallel bases. Now, I made a big point of saying, well, that might be true, that's the formula, but the reality is when we're calculating the volume of a prism, it's better to use a more, a formula that is a bit more useful. So the bit more useful formula is to remember that for a rectangular prism, the base is a rectangle. It's like stacked Post-it notes, so you calculate one area, so that would be length times width, and then you multiply it by the height. Hence the formula, the more useful formula for rectangular prism is LWH, or length times width times height. For a triangular prism, since you have two triangles, the area of a triangle is 1/2 base times height. So the base area would be 1/2 times height. And then the distance between the two triangles would be another height, which lends to a problem, which is why this formula looks very ugly, but it basically means 1/2 times the base of the triangle times the height of the triangle times the height of the prism. Okay, so we're moving on to a new shape. The new shape is called a cylinder. So a cylinder is made up of two circles that are parallel to each other, and then its sides, well, the sides are not, this is why this is not a polyhedron, the sides are not rectangles, the side is a curved surface. Okay, so that is a cylinder. So in order to draw a cylinder, you draw two parallel circles and then connect the two sides. And then for the back or the bottom cylinder, which part you don't see, we make it dotted so that it looks right. And remember, this is difficult because you're drawing a three-dimensional shape in 2 dimensions. Recall that for a rectangular prism, the formula is length times width times height, or base area times height. So when we get to the formula for volume of a cylinder, all right, we think of its base area. Well, its still BH, capital BH. The base area in this case is a circle. So let's see, the more useful formula, let's see, area of a circle is pi r squared. And then we got to multiply that times the height of the cylinder. So the more useful formula in yellow, please write this one down, is volume equals pi times r squared times h. pi is approximately 3.14. The radius squared, that doesn't mean r times 2, that means r written twice, and then the height is the height. Okay, so to do this formula, you need the radius and the height. So I don't want to say like this is truly complicated. It's not. Obviously, when the numbers get large, it's a little bit unwieldy in the calculation because you had a pi running around. So let's see how this works. So although the book will say capital BH, the more useful formula is pi r squared h. So all we need to do is find the radius and the height. Let's look at our cylinder. It appears that the radius is 2 and the height is 10. Now be careful here. This doesn't mean 2 times 20. By PEMDAS or GEMDAS, we need to do 2 squared first. That means 2 written twice. 2 times 2 is 4. 4 times 10 is 40. And so the volume is equal to 40 times pi. Now that would be the answer in terms of pi, 40 pi. So when the book ever says write your answer in terms of pi, well, you're done right there. Just put units. So 40 pi cubic feet. But if we were to multiply times 3.14, we would get that number. I'm doing a little bit of rounding there. So approximately 126 cubic feet. But just remember, that answer right there is the answer in terms of pi. And we like that answer because we can leave an equal symbol. Okay? All right, let's do one together. So here's your cylinder. Go ahead and pause the video if you know what you're doing, get to an answer, and then play the video to check it. For the rest of you, let's see. We need the radius and we need the height. What's the radius? Rectum, what's the radius? That's correct. It is 10, and it looks like the height of this prism, or the distance between the two circles, is 12. All right, so we got to be careful here. Remember, that's not 10 times 2. That's 10 written twice. PEMDAS says we got to do exponents first. So 10 squared is 100. 100 times 12 is, what do you got, Chris? 100 times 12? Yep, 1200. So that's the answer in terms of pi, 1200 pi cubic meters. But if we were to, and in most of the questions tonight don't ask you to leave it in terms of pi. They just simply say, what's the volume? So let's go ahead and multiply by 3.14. Remember, you can use your calculator. So I'm going to do some round here. I'm going to round most of my answers to the nearest whole number today. So we got 3,768 cubic meters. Go ahead and pause the video. Redo that one if you need to. Make sure you understand where all my numbers come from. Ready to move on? All right, one more together. Let's see. Oh, man, what's the problem here? What's the problem? Prudence, what's the problem here? Yeah, that's right. That's not a radius. That's a diameter. So 16 is the diameter, not the radius. So how do we change a diameter to a radius? Priscilla, how do we change a diameter or radius? That's correct. We take half. So in this case, the radius is not 16. The radius is 8. And the height is 40. Okay, so we got to do, these are large numbers, don't panic. So let's see, 8 squared, that's 8 times 8. It's not 16, it's 64. So 64 times 40 is a very large number, and that would be the answer in terms of pi. If we multiply 2,560 times 3.14, do a little bit of rounding, we get to the approximate answer. This is in centimeters, so 8,038 cubic centimeters. We okay? All right, how about we do, I don't know, one more. Okay, so here's another one where I'm giving you what? The radius or the diameter? Radius or diameter? Donovan, which one am I giving you? Radius or diameter? That's right. I gave you the diameter again. So what's the radius, Donovan? Yep, that is 5. So the height is 25 and the radius is 5. 5, it's not 5 times 2, it's 5 squared. 5 squared is 25, so this is 25 times 25. So there's your answer in terms of pi. Notice in my instructions there, I just ask you, give me the answer in terms of pi. If we were to just find the answer not in terms of pi, we multiply 625 times 3.14, and that would give us our approximate answer. All right, we got this? All right, there's 2 questions here. This is the next question on the Google Forms. Go ahead and calculate the volume of both shapes. And go ahead, don't leave them in terms of pi. Just give me the approximate answer. How'd we do? All right, I'm just going to show you the answers. The first one here is approximately 283 cubic feet. And the second one here is approximately 69 cubic meters. Are we okay? If you have any specific questions, email them to me. You can also rewind the video and watch this again. But the calculations should be fairly straightforward. All right, let's do some algebra. All right, so what if, instead of I gave you the picture of it, I just gave you some data about the cylinder? I said it's a cylinder, and this time I'm not going to give you the radius and the height. I'm going to give you the volume and either the radius or the height. Notice I gave you the volume there and the radius. What I did not give you, what you're missing, remember that's the formula, what you're missing there is the height. So let's see if we can solve this for height. So let's see, the volume is 96, so V is equal to 96. And the radius is 4, so there's everything plugged in. Now we simply do a little bit of algebra. Well, what's 4 squared? Remember, we do exponents first. 4 squared, let's see, 4 squared is 16. So how do we solve for h? Well, look what's attached to h. We got a pi, and we got a 16. And it doesn't matter which one you do first. I'll do the pi first. It works equally well doing the 16 first. So if we divide both sides by pi, because pi is attached to h by multiplication, okay, we could also multiply 16 times 3.14 as well. And then divide by whatever that answer is. But I'm going to divide by pi first. So let's see. Pi divided by pi cancels, and 96 divided by 3.14 is approximately 30.6. Last step, let's see, what's attached to h? 16. Divide both sides by 16. I mean, so this just basically turns into a little calculator drill with algebra as the basis for how we get to the answer. Does that make sense? What if I gave you the volume and I gave you the diameter? Okay, so we're going to go back to what Prudence told us. She told us that, well, the relationship between diameter and radius is a diameter is double the radius, or radius is half of the diameter. So let's see, I need radius, not diameter, so the radius, if the diameter is 8, would be 4. So when I plug everything I'm given into the formula, let's see, the volume is 96, that's the V, and the radius is not 8, but the radius is 4, so to solve for h, the same thing. We'll do 4 squared first. 4 squared, 4 times 4 is 16. Divide both sides by pi. The pi's cancel. 96 divided by 3.14 is approximately 30.6, sorry. And divide by 16. I mean, it's the same problem. I just simply changed it around and gave you the diameter instead of the radius. Okay, we good? All right. What if instead of all that, I wasn't given the radius or the height, I was given the capital B? So there are a couple tonight for homework that look like this, and you're like, well, wait a minute, where's the radius or the height? Well, remember the initial formula is volume is equal to capital B times h. So let's see, if volume is equal to capital B times h, or the base area times the height, we just plug in what we know. V is 36, capital B is 12, so this one's actually even easier. Well, check it out. What do I got to do to both sides now? Okay, Winter, what do you think? Yeah, that's right. All we got to do is divide both sides by 12, and we're done. Okay, the 12s cancel, and 36 divided by 12 is 3. So let's see, what are the units? Centimeters. So we got 3 centimeters. We're done. And it wouldn't be cubed or squared because height is a single, it's just a measurement of distance. Hey, let's do one. All right, so let's see what we got here. So we're given volume, it looks like in terms of pi, it says 500 pi cubic centimeters, and we're given the radius, which is 10. Okay, so let's see, I'm going to use the formula V equals pi r squared h. I'm going to plug in what I know. V is 500 pi. I was solving for h. And the radius is 10, so I got to do 10 squared, pi r squared h. Okay, let's see, I can do 10 squared first. 10 squared is 100, so I get 100 pi. Now look what's attached to h, because h is what we're trying to solve for here. So what's attached to h is 100 times pi. Well, how is 100 and pi attached to h? Yeah, it's attached by multiplication. We get rid of multiplication by division. So let's just go ahead and divide by what's attached to h, 100 pi. So divide both sides by 100 pi, and look what happens. On the right side, 100 and pi cancel, right? 100 pi divided by 100 pi is 1. And on the left side, well, the pi's cancels, and 500 divided by 100 is 5. So everything drops out except for 5 and h. Therefore, the height is 5 centimeters. So that one looked like it was very challenging, but it ended up being pretty easy. Let's do another one. Okay, so look at this one. So this time we're given volume and height, and it says calculate for B. So which formula has a B in it? Yeah, that one. So we're solving for B this time. All right, so let's see. The volume is 64. The height is 8. Hey, this one's not hard at all. Look at that one. All we got to do is get rid of that 8 and we're done. So how's it attached to B? By multiplication. So let's divide both sides by 8. The 8s would cancel. 64 divided by 8 is 8. And why did I say that the answer is centimeters squared? Well, let's see. Capital B stands for base area, so that's the units are squared. Okay, so area, remember, is always squared. The other ones, we were solving for h, and h is height, and that's just the distance, so that's why it's just plain old units. Make sense? All right, let's do one more. All right, so let's see what we're given. We're given V and capital B, and it says calculate for h, so we're going to use this formula again, and we're gonna calculate for h. So let's plug in what we got. Oh, and by the way, volume is in terms of pi here. So let's see, volume is 24 pi, B is 2, and we're solving for 8. Well, once again, this one isn't too bad. Look at the h, we're just solving for 8, so we'll just divide both sides by 2. It gives us 12 pi, and 12 times, 3.14 is approximately 37.68, and height would be just plain old centimeters. Yeah? Okay, quick note, the only ones that are very challenging are questions numbers 5 and 6, and that's because number 5 is not a cylinder but a tube. So see, how would you calculate the volume of a tube? Well, it would be outside volume, and then subtract the inside volume. So just think of it as two separate cylinders, a large one and a small one, and to find the volume of the tube, then you simply subtract from the larger the smaller. So it would be pi r squared h minus pi r squared h, where the radius and the height would be of the large and the small one. Does that make sense? And then the second one, number 6, it's half of a cylinder. So just calculate the volume of the full cylinder and divide by 2. It should make sense. Okay? If it doesn't make sense, make sure you send me an email. Good luck on your homework, and I will see you guys on Friday.